नहीं अभी YouTube पे कुछ भी नहीं दिखा रहा सर। दिख रहा है क्या? मेरे को क्यों नहीं दिख रहा? अच्छा, हाँ अब मेरे को भी दिख रहा है। हाँ अब मेरे को भी दिख रहा है। Hi everyone, a very good evening. I can see some comments. Very good evening to one and all. Hi everyone, a very good evening. I can see some comments. Very good evening. We'll soon start the session, guys. Okay. Alright guys, let's get started, right? And today is the second day of this AIML bootcamp. And my name is Ajitab, right? I hope you remember me from yesterday, right? Now, let's talk about what we're going to do today, right? So we're going to take up a project, right? Or, directly a problem, I should say, right? And we're going to solve it using regression problem, right? So we'll have regression algorithm, we'll train the regression algorithm, and we'll try to predict something. Okay, that is something that we're going to do, and we're going to define that problem, right? And let's see how we work. Yeah, I want to highlight a few things here. I have a data set, right? Can you just see the data set here? The data set is actually having the expenses on TV ads, right? Let's say I have a product and I want to endorse that product on TV using ads, or maybe newspaper ads, or maybe social media and all, right? So I have expenses on TV ads, yeah, and I have corresponding sales. It's a supervised machine learning problem, guys, and what we want to do is we want to predict the sales of the product, you know based on the expenses of the TV. So it's a very simple problem, right? You can see that. Okay, but we'll try to do it rigorously. That is something is the aim today. Okay, so you can just see here we have the continuous data, right? Numerical data that we have, right? So let me just define the problem. We'll directly jump into the Google Colab, right? And we'll try to define the problem there only, and we'll get started with that. And one more thing that I would like to tell you, that our aim is not only to apply a single regression algorithm. We'll try multiple regression algorithms, and we'll try to build a model which can predict the sales depending upon the TV ad expenses accurately. Okay, that is something that we are going to do. It's a complete project, guys. So let's jump into the collab, right? And let's get started. Okay, so let's get started with this, and let's create a new notebook, and let's first define the objective. What exactly is my objective in this particular project, right? Or problem statement, you can call it, right? So let me just name it. Yeah. So it's like sales prediction problem, or let's name it like sales prediction only. Now let's have a text and let's define the problem. Guys, this is the problem of almost every company who are like to endorse their products on social media, maybe TV ads, radio ads. They want to predict, right? If we spend some money on those advertisements to predict, okay, let's name it like this, to predict sales of the product based on TV ad expenses. Okay, that is something that we are going to do, right? We are trying to predict the sales of the product, right, based on the TV ad expenses. That's a simple problem that we're going to have. Okay, now what is the solution domain, right? So how we are going to solve it? So here, since it is a regression problem, right, so we would like to apply different regression algorithms. Yeah, apply different regression algorithm. If you don't know about the regression, guys, it is a type of machine learning problem when your target variable is numerical in nature, when your target variable is continuous in nature. Okay, so my target variable here is sales, right? And sales is continuous variable. So that's why I'm going to apply different regression algorithms and train the models. Primarily, I'm willing to apply 3 of the machine learning algorithms here, right? The first, the most simple one, that is linear regression. Let's have a look into this. Or, let me just tell you the step-by-step process also after mentioning the idea here. Then we will have decision tree regressor, right? I'm sorry, yeah, I think there's a spelling mistake. Decision tree regressor. So it's a tree-based algorithm. I'm just trying to give you the different algorithms and their output. Okay, we'll also try random forest regressor. Okay, now let me just tell you the step-by-step process, right? What we're gonna do. So step 1 that we're gonna have, let me just give you an outlier, right? So that you can understand what we are trying to do, and then we can implement it. So step 1, yeah, we'll load data. Step 2 that we have done yesterday, right? We'll perform EDA, a bit of EDA, and data pre-processing. That is something that we're going to have. Then step 3, right? We are going to train the different models. Yeah. Then step 4, sorry, right, is evaluate the model. Okay. Then finally we'll make some predictions. Okay, that is something that we're gonna do, guys. Okay, I hope you're getting this idea that what I am trying to do here. Okay, so I hope you got an idea that we're gonna try. Okay, let me just, yeah. Alright, so you can see we'll try different algorithms here, primarily linear regression, decision tree regressor, although we have a couple of more regressors, but just to make it simple, we'll have like this. Okay, so let's get started, guys. Let's load the data and get started. Alright, I hope you understood the problem statement. We need to predict the sales of the product based on the TV ad expenses. It's a simple problem. right? But we'll try to make it as much as detailed as possible, yeah, in 1 hour. So what I want to do is I want to complete this project in that 1 hour so that you can see the entire process. Okay, let me now upload the data set in the collab. We got the data. Again, you can see TV marketing, and this is CSV file, right? And let's copy the path from here so that we can load it. Now let's get started, guys, right? So I am on my first step of this entire project, that is load data. To load the data, we need library support, as we discussed yesterday also, if you remember. NumPy, Pandas, Matplotlib, these are the libraries we're going to use. Okay, so let's get started with importing libraries. Import libraries. Okay, let's get started. Let's import NumPy. Okay, as NP. Let's import Pandas. That's what we need, right? As PD. All right, couple of more, like we need Matplotlib. Cbon probably no, but yes, let's import it. Okay, so I've imported the primary libraries. What are the other things that I need, like regressor and other stuff? We're gonna do it later. Okay, got it. This is something that we're gonna do. All right. Now let's quickly load the data. Right. So what I have to do, right? So let's name it like df. Df is nothing but a data frame object here. Okay. PD dot read underscore CSV is the function. All right. And let's paste the path that we got from the Google Colab. Okay. And just to see the first look of the data, let's call df.head, which will give me the top 5 rows of the data. Okay, I think I have not executed the earlier cell, that's why it is giving me an error. Anyways, now we are going to get it. Yes, so you only need 2 columns. You can just see it's a simple problem that we have. Yeah, that's the TV. TV is nothing but TV ad expenses, and the sales is some number, maybe in thousand, right? You can see TV ad expenses more than the sales. This is not desirable, right? So you have to understand that these sales might be in thousands. Okay, and one more thing we can do is we can simply call, or we can simply explore the data by starting it with the info function. Very simple info function can give us that idea. Okay, so basically I am on my second step, that is performing EDA and data pre-processing. Okay, so let's have a look into EDA part. Let's explore the data. Let's first so let me just mention it as well so that you can see this. This is step 1. Step 1, load data. All right, so we have loaded the data, right? Now we are on our second step. Step 2, yeah, that is nothing but the we need to explore the data. Let's perform the EDA and pre-processing, right? Make it. All right, let's perform the EDA and pre-processing. Now let's get started with the simple statistical summary of the data, and by calling the info function we can get that. We will also call the describe function. Info function simply tells you about the data frame, right? You can see it's a very small data set, 200 entries, right? I just kept it simple, guys. Otherwise I would have taken a complex data set, and I know it will take a lot of time to pre-process the data. I will not be able to complete it in 1 hour, right? That's why I've just taken a small and simple problem. Okay, so you can just see here we have TV column, we have sales column, and the good news is, like, we don't have null values, right? Both the columns has got 200 values. That's a good thing, and both of them are numerical data, so no need to perform the conversions or something like that, right? We are good. We can also see the descriptive summary. Yeah, so let's call df dot describe, right? That's the function that we can simply call, and it will simply give me the statistical summary of the data. So you can just see that the average expenses on TV ads is 147.04, and the sales that we are getting in 1000 average sales, that is 14.022, maybe in 1000, right? You can see that the standard deviation is also shown, right? Standard deviation for both the columns. Yeah, the minimum expenses, the maximum expenses here. So at some point of time we spend $296 maybe, yeah, and we got 27 k sales. That's a good number, right? Okay, so we get some good understanding of this. Okay, all right, now we are ready to understand the data in more deeper, right? So let's get started with the histogram of TV ad expenses and the sales. Let's try and understand this, okay? And I am on EDA, right? I am doing univariate analysis, guys. Okay. If you remember, I use that term, univariate analysis. So taking one variable at a time and trying to understand the distribution, right? So you have choices, like from matplotlib you can simply have a histogram, or you can simply have a dist plot. Dist plot is distribution plot, guys. Okay, and you just have to simply pass it. So SNS is nothing but cbon, so I'm getting help from cbon. Yeah, okay, I think the key is not sales. Just a second, let me just confirm. Oh, capital S, I'm sorry, my bad. Yeah, go for it. So it's a very simple way of understanding the distribution. We can observe from this histogram, right? Right, sometimes the sales can also be negative, right? Although you can see here the sales is very close to zero. Okay, and when you see this this plot, right, you're going to easily see the histogram plus the distribution curve as well. So you're going to see the data in sales is approximately normally distributed. That's a good thing for us, right? Normally distributed. So the model will perform very good if the data is normally distributed. Yeah, we can expect the model perform really well. Okay, now similar to this, right, we can also understand the distribution of the another variable, that is TV. Okay, let's go and run it. So this seems to be bimodal, right? You can see this is a bimodal kind of distribution. There are two peaks here. Yeah, when you say TV expenses. So very interesting to see this patterns, and we can derive a lot of things out of this. So this was univariate analysis that we have performed. You can also have a box plot, right? Simply have a box plot. Let me just quickly draw a box plot as well. Right? Basically, what am I doing is I'm checking for outliers here. Okay, let's check for the outliers simply, and let's have a box plot. Yeah, box plot for the sales plus the box plot for the TV ads, right? Let's simply have it. Yes, that's a box plot. You can see there are two box plots. Okay, I think I should have it in a separate cell, otherwise it will combine it, right? That is something we don't want. Let's go for a box plot. Yes, and the good news is, right, it is reflected in the box plot also. Yeah, mean is somewhere in the middle, right? Very close to the middle value of this. Yeah, and there are no outliers. When there are outliers, no guys, then in the box plot there are always some boxes around these whiskers. Okay, you also simply have the box plot of this, so you can see it's also approximately normally distributed. That's actually a good thing for us, guys. Okay, let's also do a bivariate analysis. Let's try and understand the relationship between both of them. Yeah. So let's try a bivariate. We understood these terms yesterday, if you remember, right? Bivariate. That means we have multiple features coming together. Bivariate analysis, right? Let's go bivariate analysis, and we'll simply have a scatter plot. That will be, I think, fine. Okay. So from Seaborn, I'll have a scatter plot function, right? And I'm simply passing both the features from the data, and I'll have a scatter plot. Okay. So that takes 0 from position argument, but 2 were given. Okay. So let's simply have scatter plot from matplotlib, no problem, right? So I'll have plt dot scatter, yeah, and pass these things here. Okay, and let's say plt dot x label as TV and y label is sales. AI is helping us. Can you see that? So simply having a scatter plot can actually give me an idea that whether there is a linear relationship between sales and TV or not. Can you see? You're going to see there is a linear relationship. See, what is a linear relationship? When the value of x, axis is increasing, then the value of y-axis is also increasing. So can you see that? With TV ad expenses, you can easily understand that there's a you can fit a line in between that data. So it seems to be linearly related, right? You can see sales versus TV. Yeah, so it's very easy to understand this way. Okay, so these bullets are nothing but data points, guys. Okay, if you don't understand the scatter plot, it's very easy to understand the relationship using these things. Okay, now as the part of data pre-processing, right, uh, let's do one thing, that is standardization, right? Let's perform the next step in the data pre-processing, right? We have performed the EDA, right? Okay, we can go even more in details, but I think that much is enough. Yeah. Now, the next thing that I'm going to do is let's have an understanding of the data as the independent and dependent variable. If you know about the independent dependent variable concept, independent variable is a variable which we are going to use to predict the dependent variable. So what we have here, right? What we have in as part of the independent variable, that is nothing but your TV ads expenses. So let me just mention it. Okay. What is my independent variable? In this problem, my independent variable is TV. So based on TV, and what is my dependent variable here? Yeah, my dependent variable is sales. Sometimes dependent variable is also called as target variable. Okay, so that's the same thing, don't worry. Makes sense? That is something that we're gonna have. Okay, now what's the next step, right? We have to independently have the independent variable and dependent variable. Okay, and in machine learning, that's a common nomenclature, that independent variables are defined by the symbol x. We use the alphabet x to define that independent set of variable. Okay, so let's have x here, right? That's nothing but the independent variable, guys. Okay, and we'll simply have df and the TV ads. That is something that I'm going to have. Got it? And one more thing that I'm going to do here, since I'm going to use the values only, right? So later I will extract the values from these columns. So x is going to be TV and y is going to be sales. So what is this x? X is nothing but independent variable. See why we are doing this? Because we need to pass these things to the machine learning algorithm so that the machine learning algorithm can get trained. Okay, and this is my dependent or target variable. Okay, I hope you got an idea that we are trying to do. Yeah. Now, the next thing that we're going to do is train test split. We are doing all that data pre-processing, guys, right? You can see data pre-processing. We are preparing the data to pass it into the machine learning algorithm. That's what we are doing. Got it? So in the next step that we are doing is the train test split. Okay, that's train test split. Very important concept, right? Train test split, right? And probably we'll have 70-30 ratio. Yeah. So the ratio I'm going to have is 70-30 train test split. Okay, this is something we need to do. Okay, now why we're doing this train test split? Basically, the entire data is going to be divided into two parts. Okay, first part is going to be train data, using which we are going to train our algorithm, and test data, which is unknown data, right, which we are going to use to evaluate the algorithm, how good my algorithm is performing on the test data, like unknown data that we have. Make sense? That is something that we're going to do, train test split. And don't worry, it's so simple in Python using scikit-learn. So now I'm going to use scikit-learn, guys, another very popular library for machine learning. Let's have it simply. We have to import it first. Yeah, you can just see that AI is helping us, right? So scikit-learn dot model selection, you can just see that model selection. Okay, so from the model selection part of scikit-learn, we have train test split. Okay, and as we have already divided our data into x and y, so there will be four parts of the data, right? X will be divided into train and test. You see, I've just named those variables like this, right? X train and y, X train and X test, Y train and Y test. I hope you can see this, right? I hope you can understand this particular point. I'm just calling this function train test split, passing X and Y here, right? X and Y is nothing but my data. Can you see this? Okay. And then you're going to see here we have test size equal to 0.2, or we can also have 70-30. So we'll keep it is scaled data, right? It is in percentage, but it is scaled in between 0 and 1. Test size as 0.2 means I want test set of data 20%. Yeah, and you can keep random state as anything, right? Right now, let's keep random state equal to 0. I don't want to randomize data right now. Yeah, so let's go and check it out. Okay, I think we have not run the previous step. Yes, we got it. Now, just for exploration, yeah, I want to show you that we got 200 records, right? If you remember, we got 200 records, right? You can see 200 records. Got it? And those 200 records will be divided into train and test part. And just to understand, shapes here, shape, how much values we got, right? I'm calling the shape attribute here. This will allow us to understand how much observations we got in train part and the test part. Got it? Let's go and run it. So if we just observe, right, 160 observations gone in the train part of it, 40 are in test, and equally Y train also got 160 records, as we are doing it 80-20, right? So 20% data is 40 observation, 40 record. Okay, this is something that we got. Now one more important step here, right? When we see these things, right, when we see these things like X train, X test, Y train, Y test, these are all series, and we don't want series here. Okay, so one more pre-processing step that we have to do is extract values in the form of numpy, right? That is something we are going to do. All right, numpy array, I should say. And that's easy, right? You just have to call the reshape function, and that will be done. So if you just see, what am I doing is I'm calling x underscore train I want to transform this x underscore train again by just extracting the values. See, values function will get the values from the column. Okay, and since I want it into numpy form, I'll call this reshape function and I'll call it as -1. So it will be like vertically aligned. I'll show you that output. Don't worry. Okay, the same thing I have to do with the y part. Okay, so let's have y train. Right, same thing I'm doing. If you just understand why I am doing this, let's print those. Right, let's print the x train. You will understand what I'm doing. Can you see that? Now every value is individual. Can you see every value is an individual component in the entire array. So you can just see we have array and we have different values as individual arrays, and that exactly I wanted, right? I have to pass it to the machine learning model. So we are almost done with preparing our data. Okay, preparing our data, and we are ready to move to the part of the, although we could have done the standard scalar and couple of more things here, but I think this one is good. Okay, similarly we can also print the y part of it, right? Y train. Can you see we got the data in the form that we wanted? It's super easy way of doing all these things. We are not performing any standard scalar or any kind of encoding, because we don't have categorical variables right now. Maybe in any other case we'll also have categorical variables, right? Then we have to perform the encoding. Okay, this is something that we have in our data. Yeah. Now if you remember, like, let me just give you that recap once again. What step we have performed, right? You can just see we have performed load data, we have performed EDA, that is exploration and data pre-processing, right? Now we are on the third step. Makes sense? That is train the models. Now we have prepared the data. Now we are on the train models, right? As I told you already, we're going to build 3 of the models. Like first we'll try linear regression algorithm, then we'll try decision tree regressor, and then we call it as a random forest regressor. Random forest is super interesting algorithm, guys. Basically it follows the ensemble learning approach. That makes it super powerful. Yeah, decision tree regressor is based on the decision tree, okay, tree based algorithm, right? I'll give you a brief about these algorithms so that you can understand what am I trying to do. Although in our courses we go really deep into those things. Okay, now just to give you a brief about what we do in these algorithms, right? We just come to the ink part, probably that will be a good idea. Okay, now first algorithm that we talk about is linear regression. In the linear regression algorithm, we try to find out the linear relationship between the dependent and independent variable. That is by fitting a straight line in between the data, right, in such a way that that straight line can become a reference line. So just to give you a quick idea about linear regression, if you don't know, let's have a realistic example. Maybe that will good, right? That would be a good idea. Just have the curve and the lines to line. Yeah. Okay, that's your data. I'm directly drawing the data, and just to give you a realistic example, all right, let's talk about salary of a person. I'm going to predict the salary of a person based on the experience of a person in year. Okay, and the salary is in dollars. Make sense? Now we have some data, like historical data that I already have, something like this. These are my data points. Okay. Now in linear regression algorithm, what I do is I try to fit a straight line into the data, yeah, in such a way that I can predict the future values using the straight line. Like for an example, I have an experience of 10 years, right? So what I can do is I can have this straight line, yeah. So this is the x value, right, and this is going to be the y value. So you can see that using straight line, I can have that prediction that what can be the salary if I have 10 years of experience. Simple idea in linear regression. That's why it is called as linear. We try to fit a straight line in between this. And mathematically, it is something like this. Let's say if I just want to give you the mathematical idea, it is y equal to beta 0 plus beta 1 x here, right? And what exactly is that beta 0 and beta 1? These are coefficients. Okay, x is nothing but your variable here, like independent variable, and y is like your dependent variable. And what is this beta 0? The beta 0 is nothing but this slope, sorry, the intercept, I'm sorry. Beta 0 is that, when the value of x is 0, what is the value of y? That is beta 0. So where it intercept, that is beta 0. And when you say beta 1, right? Just a second. हाँ sir? हेलो, हाँ सर? अच्छा अच्छा, मैं करता हूँ ठीक. Alright, I think there was a disturbance because of my mobile sound. Okay. Now if you just see, this is the mathematical model and this slope is beta 1. Can you see? This is beta 1. Got it? This is mathematical idea in linear regression. So we'll try that in our data. Yeah, we'll fit the data and we'll try to fit a straight line here. That's a very simple way of understanding linear regression. When you say the next model that I have, is decision tree. Yeah, I'm sorry with that. Yeah, so it is decision tree. So decision tree model actually have different attributes here, okay, different attributes, and try to build a tree-like structure with the help of all the attributes that we have, okay, and then try to predict the future values by just scrolling or traversing that decision tree that we have built. So that decision tree is built by the historical data. Yeah, we use historical data. Yeah, historical data. Okay, we have got historical data, and then we build this decision tree. That is decision tree that we have, right? We always take decision, right? Let's say, for example, I want to go to one place, right? And there are two roads to approach to that particular. So we have multiple nodes, through which we can actually go through and pass it. Yeah, and reach the place, right? So historical data. Third algorithm that we're going to use is going to be random forest. Very important algorithm, guys. Let me just a bit. Historical data, right? Every time I'm writing that D, it is taking as a circle. But anyways, you got the idea, that data, right? Then what we have is the third algorithm that we're going to try is random forest. I think one of the most popular algorithms in the machine learning algorithms, right? We're going to see random forest. It's not tree, I'm sorry, it is forest. So what we do in forest, right? We have multiple decision trees. What we have in forest? We have multiple trees. So instead of relying on single decision tree, right, what we do is we create multiple random decision trees, right? Multiple random decision trees. You can see that multiple random decision trees here, okay, from the data that I have. And then we collect the outputs from uh, different decision trees, right? We collect the outputs from different decision trees, and then we make the final decision. Guys, this idea that we are talking about is called as ensemble learning. Yeah, it is ensemble learning, very popular approach in machine learning. Ensemble learning. Okay, random forest. So we'll try all these algorithms. We'll evaluate it. Yeah, we'll understand which particular model gives us the best results. That is what is our aim. Okay. So let's try and build that idea. I have given you some brief about these algorithms. Although we can go even more in details of it. Make sense? How that line can be fitted, right? What things we have to look into the data to fit that straight line and everything. Got it? So let's move ahead and let's try and implement, right? These three algorithms, basically regression algorithms. One more point that I want to make here, that decision tree and random forest are the algorithms which can solve the classification problems as well, right? Regression problem they solve, but they can also solve the classification problems. Yeah, I hope you are talking about these things, right? So let's move ahead and let's implement these algorithms in our project. Okay, so let's get started with this again. So the very first algorithm that I'm going to try is going to be the first algorithm, or I should say model 1 that I'm going to try. Yeah, model 1 that I'm going to try is simple linear regression. Simple linear regression model that we're going to apply. Okay. Just for this, right, we need the the linear regression from the scikit-learn algorithm, the scikit-learn library. I'm sorry, right? Excuse me. So from sklearn dot linear model, yeah, linear model. Let's import the linear regression algorithm. Right, so I'll have linear regression algorithm from scikit-learn, and let's see the outputs. Okay, and what I have to do simply, I just have to create an object of linear regression, right, and then I can train that algorithm simply. Okay, right, so let's go and create. So I'll call it as linear reg so that you can understand. That's my model. I just have to create an object. Can you see? I am creating an object, linear regression. Okay, and with that object, I am going to train my model. Can you see? The fit is the function. Fit function is going to train the model, right? It's a very common function in the scikit-learn implementation. In this step only, we are training the model, and you can see one thing. Can you observe that while fitting the model, I just use only train part of the set. If you remember, we divided data already into two parts, train and test. So I've just passed the train part of the data to train, to fit the algorithm. When you say fit, no, that's nothing but training. That's the scikit-learn way of calling the functions and everything. Got it? Now let's train it, and can you see we got something? Model is a logical entity. We cannot see it, but you can see this is the representation of the model after training, after providing or feeding the train data here. Make sense? That is something that I have. I'm done with this training part, guys. Now I have to make some predictions, and then using that prediction, I'm going to evaluate my model. Okay. The next thing that I'm going to have is, I have started training my models, right? Model 1 is nothing but linear regression. Okay. And guys, just pay attention to the comments also. There are a lot of quizzes for you, and there's a attendance sheet also, yeah, attendance form also, and the certificates will be generated on the basis of the emails that we feed into the model. Got it? Those things need to be done so that you can get certificates. Okay, so please also watch the comments and do fill that form. Okay, now let's make some predictions so that we can understand whether our model is good or not. Yeah, let's make some prediction. And how do we do it? Right, we just do it using calling a function called as predict function. It's super easy. You can see linear regression, calling the predict function and passing the test. Yeah, now you can just see that for prediction purpose I'm using test, so that I can come to know that how my data is working on the unknown data. Okay, unknown data, and you can see I have the train part to train it. So training using training data, testing using test unknown data. Yeah, so I hope you're getting this. And just to show you that how it is predicting, right, how it is predicting, this is the way. You can see these are the predictions made by my model. Can you just see that? I train the model, right, with the historical data, then I make some predictions on the test data, unknown data, and these are the values that I got. Of course, just looking into the predicted values will not make any sense, because we need a solid way of understanding the predictions, or we need a solid way to understand whether our model is good fit or not, our model is generalized or not. Okay, this is something that I need. All right, so let's move ahead. And every time when you evaluate the algorithm, right, let's say evaluate model, so based on the choice of the model, like we are solving regression problem, right? So based on the regression problem, we have couple of performance and error measures, right? So we have R square value, that is most popular in R squared value, yeah? Most popular measure to understand the performance of a model, particularly in regression problems. All right, so you can see this is R squared, and let's say if you are interested in how much error that we got here, so we can think about MSE, that is mean squared error. Okay, we go really deep into these things while we do it. We have limited time, that's why I'm just giving you that idea. We can also think about RMSE and MAE. RMSE is root mean squared error. These are errors, guys. Okay, MAE is mean absolute error. So we can think about R squared value, we can think about MSE, RMSE, these things, right, to evaluate the regression model. Okay, and don't worry, right, these all things we have in scikit-learn. Scikit-learn is super useful library, guys. Okay, so if you just see that since I need to have these things multiple times, I'm going to train my two other models as well, like the decision tree regressor and random forest regressor. Okay, so I need that multiple times. So what I'm going to do is I'm going to import them. So whenever you think about the evaluation, you have to look into this matrix part of this scikit-learn. So you have scikit-learn.matrix, and we have R squared score, R score, right, R2 square score, or R squared, whatever you think about, no problem, right? It's same. Then we have mean squared error and mean absolute error, and we'll be actually we'll be actually calculating all those errors. Okay, let's run it. Okay, so let's start with the model that we have, right, and let's try and understand the different measures here. Okay, so this is for model 1, guys. Okay, this is for model, or I would say model 1 performance. Okay, now what I'm going to do is I'm simply going to have R squared value. Yeah, then let's also talk about the RMSE. Okay, let's print it. simply like this. So you can see I'm not doing anything fancy here. I'm just calling the functions which I have imported already. You see, mean squared error, passing the y test and y pred. So whenever you evaluate any machine learning algorithm, no, you have to think about two things. Yeah, think about two things. First, actual data. So what is my actual data? This is y test, right? This is my actual data. And think about predicted data. So that's nothing but the y pred. Y pred is nothing but data which is predicted by my algorithm, and y test is the data which I got in in the actual data. So let's see how my model 1 is performing. Yeah, okay, and let's run it. So that's good, right? You can see the model is performing like 67% accurate, 67.6%. Okay, the RMSE that we got is 3.19. That's also good, right? It's not a big error here. So my model is performing good. Model 1 performance is good. You see 67%. But as we have already planned, right, we'll try two other different models as well. So let's try and let's see, right? At the end, we'll conclude that which particular model gives us the best results. Okay. So let's go for the model 2. Yeah, model 2. Very similar approach, guys. Okay. Decision trees. Okay. Implementation wise is not very difficult, but the way the algorithm is trying to understand the hidden patterns of the data is different. Linear regression try to fit a straight line. Decision tree is a non-linear model. It try to fit the tree based things inside that. Okay. So when you see decision tree algorithm, right, you just simply have to again create the I think we have not imported the decision trees, right? So let me just import first. So from scikit-learn dot tree base part, right? Let's import the decision tree regressor. Okay, simple decision tree regressor, and I'll also import the random forest here, because there is already okay. Random forest is not there in the tree part. There is an ensemble part. I'm sorry. From scikit-learn dot ensemble. Yeah, let's import the random forest regressor. Okay. All right. Let me just import it here. Okay, and then in another cell, let's have this decision tree regressor first, and I'll evaluate everything here. Okay, it is very similar in approach, right? You can see you are creating an object here. Yeah, the decision tree regressor. Okay, fit function using x-train and y-train. Very simple approach. Okay, now let's make some predictions here, then only we can so I'm doing it in a single cell now, right? So let's make it like y pred. Yeah, this time the y pred is coming from the decision tree regressor model. You can say dt reg and predict function passing the x test. Makes sense? And then in the same cell, let me just copy these things so that we can have everything in one go. Check it. This time it is model 2 performance. I'll have y pred from here, y test already there, right? R squared value, which is nothing but a function here. But this time I'm talking about model 2. Yeah. So let's go for it. So can you see that my R squared value got dropped in this entry? Can you see that? 40%. Okay. And RMSE also goes up, right? So a model, right, having higher error, जिसका error ज़्यादा हो, right, ऐसा model हम कभी भी prefer नहीं करते, right? और आप देख रहे हो R squared value भी drop हो गया मेरा, 40 पे आ गया. Earlier value मेरे पास 67 था. ठीक है, तो 67 है, यहाँ पे 40 है. चलो एक बार अब थर्ड एल्गोरिथम भी देख लेते हैं. लाइक लेट्स ट्राई द थर्ड एल्गोरिथम व्हिच इज रैंडम फॉरेस्ट रिग्रेसर. ठीक है, और उसका परफॉर्मेंस भी एक बार चेक करते हैं. नाउ next model, okay, I should take text here, right? Model 3 which I am trying to do is random forest regressor. Okay, let's try random forest regressor here, and I've already imported, so no need to do that. So random forest reg, that's the model name that I'm doing. A very similar approach, right? Random forest regressor object, fit the algorithm using X train and Y train, predict some data, and again pass those predicted data into these functions. Let me just copy it. It's very repetitive code, right? That's why I'm just copying it. You can just see, okay, you can see that third model performance, and let's go for it. So if you just see that R squared value for random forest is slightly improved than the dysentery, but still not touching the performance of the linear regressor. So in this case, linear regressor did a good job. You can see that. Okay, linear regressor is the model which gives us good results, right? Because random forest also gives us high RMSE values because the errors are high. Okay, the least error that I got is 3.19, which is from linear regression model, and that's a good thing. Makes sense or not, right? So we'll finalize our linear regression model, okay, as our final model for prediction. Yeah, and now I'll quickly have a short code in which I'll have users data, users input, and predict the value. Okay, let's see how it works. But you're going to see after these experiments, we come to know that our linear regression model is performing really well. So let's make that, although we can do a lot of things to make it even better, right? We can perform the regularization. Regularization is a advanced concept that we can apply on the linear regression even to make it better. Okay, so let's have the idea of I should make it like this: prediction on user input data. So I'm interested in, if I give some input, some new value, right, to the model, how much it can predict. Okay, so I'll have the TV ad expenses because that's my thing. So I'll call it as like this: TV ad expenses. Okay, there's something that I'm going to get input from the user. Okay, I should call it like prediction on user data, user input data. Okay, now I'll call it as TV ad expenses. Let's have input from the user. Okay, and input function will help us here, and enter your TV ad expenses, or I should say enter TV ad expenses. Let's make it like that, no problem, right? Expenses, and then what I want to do is of course it is going to be an array form, so we have to process that input in the desired form so that we can pass it. So simply the same process that I have performed already in pre-processing, I'm doing it like this. So you can see the data that I have. Okay, so just see TV ad expenses being converted into array form, and then you just see the reshape that was needed, guys. Okay, and now I'll have predicted sales. Okay, how I'm going to predict that sales? I have decided that linear regression model is my best model. So I'll pass that linear regression. I pass that new data to the linear regression model into that predict function simply, and I will allow my model to predict the data for this, and I'm going to have that predicted sales with this. One more thing that I can do, I can multiply it with 1000 so that you can see the actual data. That's a very small experiment, guys. I mean, you can also create a UI to get input from the user and do it more sophisticatedly, but I'm just trying to give you the final outputs. Let's go for it. So you can see it is asking for the TV ad expenses. Let's say, for example, I'm planning to spend $250 on TV ads, and I am expecting, I'm expecting some sales. How much sales I can expect? So can you see the sales I can expect is like this. I can also pass it into round off function, right? Let me just pass it, otherwise there's going to be a lot of data. So I'm passing that into round off function, and I need only 2 places of decimals, right? Find it in the place, yeah. Check it. So let's say $250 that I want to spend on TV ad expenses. I can expect, okay, round method. What's the problem? And the array is not defined around method. Okay, got it. So there's going to be a value, right? And there is a numpy array which we got, right? Let me just check. So predict numpy array, or let's do one more thing. Yeah. Spread sales equal to yes, that is going to be a good idea, because we just need one value, right? That is going to be good. Let me just try this. Probably it should work. No, it should not, right? Numpy doesn't define the round method. I think the round function is not working here anyways, right? Without round also we can get the results as we have already seen. I think the numpy is not numpy library is not the round function. No problem, right? Let's go for it. So we'll see if I expand. Yeah, I think that's because of this, right? Yeah. Yeah, I'm sorry for these iterations. You're going to see the predictions made by that, right? Just ignore this 2, right? Just because of that 2 which I have just shown, right? So if you just see, this is the expected sales, right? This is the expected sales which we can have. Yeah, we can also extracted the value of that anyways. Okay, but I hope you're getting an idea that how we get the input, right, and how we get the output as the predicted sales. Got it? So this is the way we are trying to do this. Yeah. Okay. So I think we are not predicting that anyways. Yeah. Let's say I am changing my data, right? Let's say I want $270 to be spent on TV ads, right? So I can expect 19,714 sales. So I hope you're getting an idea, right? What we did, right? Let me just give you a quick heads up, right? We got our data. Yeah, we got our data. We defined the problem that we want to predict the sales of the product based on the TV ad expenses or any other social media ads or something. We have planned to apply regression algorithm, and we tried 3 different models like linear regression, decision tree, random forest. We have defined the steps, and then we imported some libraries. We see the data here, right? We explore the data using that describe function, info function. Yeah, we see the distribution of the data here, in the univariate analysis. Okay, and a couple of more things. Can you see that? Yeah, this is another distribution. This is the box plot analysis, so that we come to know that there are outliers or not. Okay, this is a scatter plot that we have seen just to understand the relationships. Okay, then we segregated the dependent variable, right? Then we have processed the data, to transfer it into machine learning algorithms like X-train, Y-train. Okay, we have passed that data. We have just processed it before this. Okay, and then we pass that data into machine learning model. We started with a linear regression model. Yeah, we trained the model, then we got some predictions here. Okay, and then you can just see here we evaluated the model, and we found that the R squared value for the linear regression model was 67%. That was good, right? But even we tried different algorithms, right? We tried the decision tree. Yeah, then you can just see 40% output that we got, right? Errors was also high, right? If you just look into the errors, they're also high as compared to the linear regression model. Yeah, we also tried a random forest regressor. The values are slightly improved, okay, but still they are less than the linear regression model. Errors are also high. So finally we made a decision that linear regression model in this case works really well. Okay, and then we made a prediction using that linear regression model, yeah, using the user's input, and we got the results here, right? Although we could have done, some Streamlit application, and we can perform that fancy UI, right, to get the input and show the outputs. But I think that's the basic way we can do it. Getting it, guys? I hope you enjoyed the session. I just extended it, by 5 minutes, but I hope you enjoyed the project that we did, guys. Okay, we have limited time. Otherwise, we actually go really detailed into the real course. We are planning to have a new batch of this course, guys. Right? If you are interested, then connect with the team. That they will help you uh, with the tenure and the curriculum and everything. Okay, so you can talk to the team. I hope you enjoyed the session, guys, right? And thank you so much for joining, right? I tried to make it as detailed as possible, but just because of limitations of the time, we couldn't go very deep. But yes, you know, I hope you got some idea about this way of doing that machine learning. Yeah, it was great interacting with you guys, right? And maybe I'll see you in the real course. Thank you so much, and have a great evening, and take care. Thank you.